Okay, students, can you hear me?
Yes.
Yes, sorry, just now I thought that I never. Okay, do we, the day we start this paper, do you have any question from this paper? If you don't have question, then I'll come out with, I select questions. Okay, up to you. Any questions from this paper? The day we discussed this. 9. No question? Okay, then I select question.
Sir, I have a question.
Yeah. What number?
It's 30 something, I forgot. It's about a potential meter.
Oh. $30 something. Oh, okay. Later. Oh, this one.
Yes, sir, this one.
Okay, class, come on. Let's we work together. Okay, the diameter, the diagram below shows a simple potential circuit. Small EMF produces by a thermocouple. Okay, thermocouple is a type of thermometer, measure voltage. The meter wire PQ has a resistance of 10 ohm. Okay. So this wire has 10 ohm. The driver cell has a EMF of 4.5. The balance point obtained 0.6 meter. Long PQ. Measuring EMF is 3 millivolt. What is the value of resistance R? Okay. We work based on V proportional to length. Greater the length, greater the voltage. So V1 over L1 is V2 over L2. This is based on this law we work on. Okay. Last time we used to ask you to tell, ask to fill up 100 cm. How many volt? And we found to be 60 cm. We found is 3 millivolt. Okay. So you need to find this first. The 100 cm wire uses how many volt first? Okay. Once you know this voltage, once you know this PQ voltage, the PQ voltage, the PQ, this is PQ, this question mark is actually voltage of PQ, 100 centimeter. Once you know the voltage of PQ, you can find the R by using the first loop. Okay. How to find the R? Because PQ is how much? 10 ohm. 10 ohm uses how many volt? The voltage PQ which you're going to find. Okay. The R plus 10 ohm uses how many volt? 4.5 volt. You can find the R from here. Okay, first find the PQ. How to find the PQ? So VPQ over 100 should be equals to 3 over 60. We use this formula. V proportional to length, so V over L is constant. So anyone, what is the PQ value you got? This is millivolt. millivolt, you can change to volt lah. So it's going to be 0.003, 0.003 volt. So PQ you get in terms of volt. Anyone? What is the PQ value you get? 100 over 60 times 0.003. You get the PQ,
0.005.
0.005. Okay, then, so that means PQ I cut here is 0.005 volt. So 10 ohm uses 0.005 volt. R plus 10 ohm uses 4.5 volt based on the first loop. The 10 and the R share the 4.5 volt. So find the R. How do you put this? Okay, sorry, I can do here. So 10 ohm is 0.005 volt. R plus 10 ohm is 4.5 ohm volt. So 0.005 volt over 10 ohm equals to 4.5 over R plus 10 ohm. So find the R. So R plus 10 ohm equals to 4.5 times 10 over 0.005. Then you minus the 10, I put it there, minus 10. Get the R. Anyone got the answer? So what is the answer you get? A, So you get A. Okay. A. So do you understand? So you always must find these two. 100 cm, how many volt? Don't know, whatever length they give, that cm, how many volt? You need to find these values first.
But sir, if they don't give the length of PQ, can we just assume it's 100 cm?
Yeah, you take it as 100 cm. If they never give anything, you should take it as 100 cm.
Okay, thank you, sir.
Okay. Here they never mention it's 100 cm. Oh yeah, they never mention. You take it as 100 cm if they never mention. Any other question?
20.
Okay, we go to 20. Okay, the others, give a try. Question 20. This is your deformation of solid. Okay, sorry. Two steel wire P and Q have a length of L and 2L. Cross-sectional area A and 2A. Both wires obey Hooke's law. What is the ratio of tension Q and P over P when both wires are stretched to the same extension? Okay. So make it shorter so I can use this. Use this. Okay. Okay, see, can't hide it anywhere. Okay. So wire P, L, and what? wire P, L, and A. Okay, do from here. So wire P is L and A. Okay. A, L, wire P. Wire Q is what? Wire Q is 2L and 2A. 2A and 2L. 2L. Okay. They said the tension is actually the force law. Force of P, force of Q. Okay. What is the ratio of, question asking, what is the ratio of FQ over FP? Okay, sorry. FQ over FP. That's a question asked. FQ or FP. So tension Q or tension P is FQ or FP. Both wires are stretched to the same extensions. Extension is same. They extend the same extension. Okay. So now let's open this. So yeah, FQ or FP. So what formula to be used? Young modulus. Both made of same material, right? This is both made of same material. Two steel wires. So two steel wires. So same material. So same material, Young modulus same. So we said Young modulus of P same as Young modulus of Q. I put the other way around. Young Q same as P. Easier for me. So what is Young modulus? FQ over A, what? Extension original length. Correct. So the Q is actually, L is how many L? 2L. How many A? 2A. Okay. For the E is what? FB. L is L. A is A, extension X. For me, I find FQ over FL. So what do you get? I think you get 1. Get 1. So answer is it? Answer should be C. C. Is answer given C?
Yes.
Yes. So you got the understand the working?
Yes, thank you, teacher.
Okay. So yeah, so this is 1. Any other question?
Sir, question 33.
33.
Yes.
33. So you go to question 33. Yeah. What is the effective resistance between the point AB resistance at 10 ohm each? This is a good question. So all are 10 ohm. All of them are 10 ohm, 10 ohm, 10 ohm. Okay, 10, 10, 20, 20. You see, I choose 2 points here. This point X and this point Y. If I use my hand, I pull the Y up and I pull the X down. We're going to rearrange to this format. Do you realize this? Okay, so if you pull the X and Y up, it will rearrange like this. So 10 here, 10 here, 10 here, 10 here. Okay. So what happened? The potential here and here will be the same, because you see the current flows from here to here, 10 ohm here, 10 ohm, So the potential here and here will be the same. Therefore, no current will flow through the center resistor. No current will flow in the center resistance because potential is same, 10, 10, 10, 10. So the potential at this point and this point is the same. So no current will pass through this wire. So this center resistance is not included. So the resistance at the top is 20 ohm. Resistance at the bottom is 20 ohm. So these two resistance consider parallel. So the effective resistance is 1 over 20 plus 1 over 20. So the effective resistance you get 10 ohm. So answer is C. Okay. So there won't be any current flow at the center resistance because you see up here 10 ohm, 10 ohm, here 10 ohm, 10 ohm. This is again, you can rearrange like this also. It's like this. This is like this, connected. They are connected. This like A and B. And there is one other resistance here. This circuit is actually this. You can visualize like this too. Okay. So if this is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm. The voltage here 1 and the voltage here 2. Voltage 1 will be same as voltage 2. So no current will flow. So this resistance is not counted now. If not current not flow, the resistance is not counted. So then up is 20, down is 20. So they are in parallel. So you get effective resistance 10. Can you understand?
Yes, thank you, sir.
Any other question?
29.
29, eh? Okay, 29. A tube of length L is open at both ends. A stationary wave is set up in this tube and the tuning fork vibrating with frequency fx is held on end. This is the lowest frequency of the stationary wave that can be formed in this tube. So fx is the lowest frequency, means the pattern should be like this now. The pattern should be like this. So the L should be half lambda. Okay. So L should be half lambda. For the first case, it's open pipe. Another tube length 2L are closed at one end. The stationary set up in this tube. And the tuning fork vibrating with the frequency of Y is set at the open end. This is the lowest, this is also lowest. Lowest frequency can be found in the tube. So here is a closed pipe. The appearance should be like this. So the 2L equals how many lambda? This how many lambda? Quarter lambda. You look at this diagram, this is what two things you have to visualize. The first one is L equals to lambda over 2. Second one is 2L equals lambda over 4. Assume the n of correction for each tube is negligible. N correction not in your syllabus. So you don't need to worry about this. N correction means in reality, it won't be, the quarter lambda will be slightly out of the tube. Slightly out of the tube. So it's going to be L plus the X line. N correction is lambda over 4 in reality. But in your syllabus, N correction is not considered. So your L equals to lambda over 4. So which equation is correct? So they are comparing. So how to find this? This is lambda 1. This is lambda x. Lambda x, this is lambda y. The only relation same is the L. From this first equation, what is the frequency fx? V over lambda x. So it will be V over, in terms of L, how much? 2L. Because lambda x is 2L1. 2L. So fx is V over 2L. How about fy? Fy is V over lambda y. V is V. Lambda y is what? Lambda y?
8L.
So it's 8L. Yeah. So now you compare these two. How to compare? Compare the L. So L here how much? V over 8Fy. L here how much? V over 2Fx. So compare these two. So I write here, sorry, no space. So these two compare. V over 2Fx equals to V over 8Fy. Yeah. So V cancel. So 8Fy equals to 2Fx. So 4Fy equals to Fx. So 4Fy. So Fy is Fx over 4. Fy. So D now. Right. Answer given D.
Yes.
Yes. So this is the working. The thing you need to know is the pattern. For the open pipe, the pattern is like this. Closed pipe, its pattern is like quarter wave. Open pipe is half wavelength. You know the pattern that you can do. Okay. Any other question? Which part you don't understand here? Any part you don't understand? So it's actually what do you call derivation only lah. You must equate the length finally, because the length is the same what do you call variable in both sides. Okay, so we equate the L. Okay, any other question?
No, question 11.
11. Okay, guys, come on. Question 11. So the others who haven't tried, give a try. 1 minute. Oh, this is approach each other. The diagram is wrong now. Why they put acceleration? Two objects M1, M2 approach each other along a straight line. Approach each other. So we follow the question. They approach each other. That means M1 is moving to the right with V1. M2 is moving to the left with V2. I showing the object collide and stick together. After that, they stick together. What is the total change in linear momentum of the object as a result of the collision? As an acceleration. What is the total change in linear momentum of the object? Total change. Total change. M1, M2. Oh, so what is this? And say 0 lah. 0. Right? No change in momentum. What principle of conservation of momentum say? The total momentum before and after is same, right? The total momentum before initial should be same as total momentum before. It should be same as total momentum after. The question asking for what is the total change? Is there any change? Total before and after. What is the change? Change is 0, right? The total after the final minus the total initial will be 0. So there is no change. If there is a momentum change, the total momentum change, then the conservation of momentum is not applicable. So answer is 0. 0, yeah, it's definitely 0. It's a tricky question. Answer is 0. Any collision, any type of collision, total momentum before and after is same. So there is no change in the total momentum. Only some momentum, maybe body A loses momentum, the body B takes that momentum, but the total momentum will remain the same. So no change. You understand?
Yes, thank you.
This is a tricky one. This one. Any other question?
Question number 12.
12, okay. Okay, students, question 12. So it's F versus time. So you should know F versus time, area under graph represents what? It is F times T, right? F times T is actually MV minus MU. Okay? MV minus MU. So FT is actually the change in momentum. So FT is MV minus MU. So the area is actually changes in momentum. So what is the momentum of the body during the 4 seconds? What is the change in momentum during 4 seconds? 4 seconds up to here. So up to here, you find the area before the 4 seconds, how much? That is a change. So this area before the 4 seconds is the changes in momentum experienced by the body. So the area is the changes in momentum. So find the area. So what is the area? It's a trapezium. So R times width is how much? 3 minus 1, 2. Plus top is how much? It's 1. Height how much? 5. Yeah, 5. This is change in momentum. Up to 4 seconds. Up to 3 seconds also same. You have to find the area before that time. That is the total changes in momentum. Okay. 3 to 4 actually no changes in momentum. But 0 to 4, the total area before the 4, that's our changes in moment. So yeah, so what do you get? 15 divided by 2 is 7.5 ns. This is your changes in momentum. Please answer. Got the idea?
Yes, yes.
So find area before that time. Yeah. Any other question? No questions? Then we go to the next paper, maybe. No questions, huh? So the others can be done. Okay, guys, so we go to the next paper. Those who haven't tried, please try this paper. Okay, so that's a paper 1 Gen 18. Paper 3, not paper 3, Gen. Paper 1, paper 2 Gen 18. Any issues? Anyone have any issues? Then I can open up the paper. So hopefully the mark scheme should be quite helpful. We go to the paper 1 Gen 18. Another one. Oh, this is the same paper. Same. Maybe I. Oh, it's a different paper. I think coding is the same. Okay, anyone tried this paper? Oh, this question we done before. Yeah, only that question is similar, repeated. Anyone tried this paper? Nobody tried, huh?
This paper we discussed already.
We discussed this paper already. Yeah. Okay. Paper 1 Gen 18. Okay, then any other paper? Paper 2 July 17. You tried? Anyone? So we go to paper 1 July 17. Okay. Open up this. Okay, paper 1 July 17. Anyone tried this paper? Nobody tried? So then I select the questions. Okay, let me select the questions. Okay, the question I like to select is okay, number 6. 1 minute for you. Get me the answer. You can tell me in the group now, or you can WhatsApp me if you want. Anyone got the answer? Oh, this is, I think, straightforward. What formula comes to your mind? Lambda equals to, yeah. So lambda equals to ax over d. So they're asking percentage of changes of L lambda or lambda should be changes of A over A plus changes of X over X plus changes of D over D. Then all multiply by 100. Should be able to get the answer because we're looking for changes of lambda or lambda times 100%. The changes of A over A times 100. Just take slit separation 0.02 over 0.5. 0.02 over 0.5 times 100%. You get a percentage for changes of A. And do the same thing for the X and D, you'll get the final answer in percent. So what's the answer?
Donkey.
All of you got D, yeah? Okay, I hope this is the working. Let's come to your mind. Do you need to change the unit? Do you need to change the unit? No need to change. Cancel sign. Not necessary. Okay, we go to another one. Hope everyone get D. Okay, another one is question 10. One minute for you. Block of weight W being pulled by a force of T. The block is not tilted up. With N, the normal reaction of the horizontal surface on the block. And F, the friction between the block and the surface. Which of the following diagram shows the correct line of force? Which vector diagram is correct? This is a little trickier. You must go for the best answer. Anyone? Can give a try if you want. You can WhatsApp me. Which do you think most likely could be the answer?
C.
Yeah, good. Yeah, the answer is C. Yes, the answer should be C. Okay, tension, it's acting here. No doubt, all diagram the same tension, the tension. The friction have to act at the bottom. So yeah, opposing the movement, correct. All the friction also the same. Problem is the weight and the normal. Weight definitely must act at the center of the object because it's a uniform object, we assume. So yes, W must be at the center. The culprit is the normal force. Okay, normal force. When you pull the object up here, the object will, like, when you pull up here, the object, if suddenly is stuck at this corner, it sometimes it can tilt a little. This can move up. Okay, if it's something stuck here, suddenly move forward, then suddenly stuck here. The object is tend to move up here. So the normal force, right? The normal force, the entire surface won't press the ground with this equal amount. The force might be shifted to the right. The action will shift to the right. So the normal direction will shift to the right, close to the pivot. Become close to the pivot. Because this surface lose contact at the ground, most probably. Okay. The one on the right still will be in contact with the ground. So the normal force will be shifted to the right, to the point where the surface is still in contact with the ground. So C is the most best answer. Okay. So you learn something new here. What you learn? The normal force location can change. Okay. The weight location won't change because it acts at the center of gravity. But normal force can change. Like same thing. Let's say you are standing. Okay. Of course, the both feet pressed on ground. The force acting up, the normal force uniform, maybe we act at the center of your body. But let's say you are tilting, yeah. You are like an inclined surface, like you are tilting. Let's say you try to press your entire weight to the right leg. Okay, you try to lay. Maybe you lean to the right. Okay, to the right. So I think your normal force won't be at the center anymore. It will shift to the right because more force action here than this feet. So it will shift to the right. The normal force will shift to the right where the contact is greater. So C should be the answer. Understand? Can any question from question 10? Okay, another one. This one, okay lah. Okay. Oh, we done this paper. Oh, some questions, I think. Okay, it's all okay. It's all okay. Observable interference pattern. So it's fine. Current, charge, particle. Metal plate. What is the electric field strength? WXY. Okay. Yeah, this is 31. What is the answer for 31? You will try 31. Okay, anyone got the answer? What is the electric field strength at X, Y, and Z? 1,200. 1,000. Yep. Anyone? Guys? So the answer should be C, right? All of you should get C, right? The 2000 minus 800 is the potential difference. Electric field strength is V over D, so V is 1200. Divided by the D is the plate separation, which is 4, so 0.04. So you get 3 times 10 power 4. And ZYX must have the same electric field strength because the plate does not change, right? Points X situated in the same space between The plate separation does not change. This Z, Y, X, only one particular point in this plate separation. So all of them have the same electrical strength. Answer should be C. Okay, so I hope you understand this part. Okay, class. So proceed doing the paper. Okay, so we're done with those who haven't tried. You must proceed, do more questions. So next class, maybe you can try paper 1 July 17, the one I discussed some questions. Then you go ahead with the paper 1 Jan 17. Jan 17. July 17, Jan 17. You can intermediate, expect you to do the paper 2 also. Paper 2, of course, carries the most of the mark compared to the objective. But I believe the mark scheme will be more useful to explain the cooking. Okay. So any questions, guys? So no question, we can stop here. So next class, I expect you to do the paper 1 July 17 and paper 1 Jan 17. And you have a look with the paper 2 Jan 17. Okay. So you will be more prepared. More to explore. There are a lot of questions. Yeah, give a try as much as you can. I guess, any questions? No question. So I stop here. Then I see you tomorrow. Or tomorrow don't have class. So I see you on Friday. Friday do more papers. Okay. Okay. See you then. Bye.